Okay, sorry for the abrupt stop of the previous video, but it only allows 15 minutes. So some things I wanted to point out about the proof. We got through all 12 steps, but remember you could have named your triangles differently than I did in step 5, but still show the corresponding parts in the right order. And some of the steps that I showed you could have put in a different order as well. But remember, you have to show the two things that make up a perpendicular bisector. So you have to show somewhere, like I did in step 3, that AD and DC are the same length. That is proving you have a bisector. And you have to have somewhere in your proof where you have a 90-degree angle, because that proves you have a perpendicular segment. So you have to have both parts for it to be a perpendicular bisector. All right, so here we're going to be introduced to what it means to have a side opposite of an angle. So in a triangle, the side opposite of an angle is the side that is not contained by one of the rays that forms the angle. So for example, in this triangle ABC, if we're looking at angle B, the rays that make up angle B are ray BA and BC. So which side of the triangle was not one of those? Well, that's AC. So AC is the side opposite angle B. So using that definition of an opposite angle, we can restate the Isosceles triangle theorem. So we know the Isosceles triangle theorem as saying if two sides, well actually it says if you have an isosceles triangle, then the base angles are congruent. So if you remember on your homework last night, 10.2, you had to state the hypothesis and the conclusion of the Isosceles triangle theorem. Remember, when you state the hypothesis, you do not write the if word. You write the if statement without the if word. So your hypothesis would be a triangle is isosceles. That's your hypothesis. A triangle is isosceles. The conclusion is the then part, but you don't use the word then. So your conclusion should have been the base angles are congruent. Well, we're restating the Isosceles triangle theorem to state this opposite relationship. So it says if two sides of a triangle are congruent, then the angles opposite those congruent sides are also congruent. I want you on question 3 in your notes to try to write the converse of that theorem. Remember, the converse is switching the hypothesis and the conclusion. So go ahead and pause the video, and then you can restart it to check your answer. So let's see how you did. The converse should look something like this. It states if two angles of a triangle are congruent, then the sides opposite the congruent angles are also congruent. So basically everywhere the previous one said sides, you changed it to angles, and everywhere it said angles, you changed it to sides. That makes the converse. So what do you think? Do you think this statement is always true? So what I want you to do on question 4 is to try to prove the converse of the isosceles triangle. So remember, to do that, to prove that, you had to state that you had a median of the triangle. So that might be helpful again. Okay? So it says here in the green though, in this case, instead of making a median, you might want to add an angle bisector instead. So you might want to connect A to D and make an angle bisector. When you finish, go ahead and check the proof, which will be on the video next. But again, you need this practice. You need to practice doing proofs on your own. So don't just continue the video and watch the outcome. You need to try it on your own. Pause the video and restart it. Okay, so this is just a possible proof for the converse. Remember, there's more than one way to do this. And you can see that I drew in that angle bisector that I suggested that you do. You could have done a flowchart proof as well, or a paragraph proof. I just prefer 2-column proofs, so that's the way I went with it. So remember, we're given triangle ABC, and we're given the base angles are congruent in the converse. The original one, you're given the sides are congruent, but the converse, we're given the angles are congruent. And we also are making an angle bisector here. So segment BD is a bisector of angle ABC. Those are my given. I'm trying to prove that that means the sides opposite those angles are congruent. So I'm trying to prove that AB is equal to BC. So obviously I'm going to start off with one of my given statements here, that angle A is congruent to angle C. I put the second given on a second line, but you could put these on the same line. That would be fine as well. Okay, so since BD is bisecting angle ABC, what can I say as a result of that? Hopefully you know what it means to be an angle bisector. So hopefully on your next line you have the two parts that we created that have equal measures. ABD, which I can mark with an arc here, and CBD, which I can mark as an arc here. Those have to be congruent to each other if this is an angle bisector. And that is using the definition of what an angle bisector is. So remember, we're using congruent triangles as a tool. That's always our goal. So do we have enough information to prove these triangles are congruent yet? I would hope you would say no, because we only have two angle pairs at this point. But remember, what we already know is the fact that they share this side BD. So my fourth step in the proof is saying that BD is equal in measure to itself, and that's using the reflexive property. Remember, I said that would come up a lot when we get to congruent triangles, and here it is. So now we have these two angle pairs and a side pair. So is that enough information to say the triangles are congruent? Yes, two angles in one side is always enough. Now we have two shortcuts. It could either be ASA or SAA. Is the side the included side or the non-included side of these two angles? I hope you recognize it as the non-included side. So we're going to state the two triangles are congruent, making sure we line up those corresponding parts. A corresponds to C, those are my base angles. B and B correspond, remember we've already proven those are 90-degree angles. And D and D, B and B are up here, and D and D are my right angles. So the shortcut is SAA, not ASA, because this is the non-included side. Now, what almost always follows congruent triangles in a proof, I hope you've recognized that by now, Cpctc is next. What are we trying to prove is true? AB is equal to BC. Well, notice AB is the first two letters of this naming, BC are the first two letters of this naming. Those are corresponding parts of congruent triangles. So I can now state that AB is equal to BC by Cpctc. So this proves that anytime you have a triangle that has two congruent angles, it has to be isosceles. If it has two congruent angles, it must have two congruent sides. All right, so we have now proven the isosceles triangle theorem and its converse. So how do you know which one to use in your proof? So remember, the original theorem says if you have two congruent sides, then you have two congruent angles. The converse says if you have two congruent angles, then you have two congruent sides. So in question 5 in your notes, we're matching each statement with which appropriate theorem there is. So in the first one, if you have these two congruent angles, how do I know I have two congruent sides? Remember, that's the converse. This is the converse of the isosceles triangle theorem. Because the original theorem says if you have two congruent sides, then you have two congruent angles. So this is the regular old theorem, isosceles triangle theorem. Okay, so one more concept to look at here is a useful extension of that isosceles triangle theorem and its converse, which allows us to put in order the lengths of sides or angles of a triangle. So let's look at this animation to help us visualize that. So in this triangle, it gives me all three of the angle measures and all three of the side lengths. And so I want us to be looking at, is there a relationship between an angle and its opposite side? So if I look at these three angles, which one is the largest? I hope you would see angle ABC. That's the largest. So where is ABC? It's the one with one arc here. Well, where's the longest side? Well, that's AC. So ABC was the largest angle, and side AC is the longest side. Do you see that they are opposite of one another? They're across from each other. Let's look at the smallest angle. That's ACB. That's the one that has two arcs here. What's the smallest side? AB. Is that across from angle ACB? It sure is. Okay, so the medium angle, CAB, is the one with 3 arcs, and the medium side is BC, the one across from it. Well, does that always hold true? If I make a different triangle here, is that still true? Let's look at the largest angle, ABC. I still made it ABC. Let's make it something else. There we go. All right, so the largest angle now is ACB. It's got 2 arcs in it. Where's the largest side? AB. Oh, that's across from it, isn't it? Okay, where's the smallest angle? ABC, the one with 1 arc. Where's the smallest side? AC, across from it. So do you see there is a relationship between an angle and its opposite side? The largest angle is across from the largest side. The smallest angle is across from the smallest side. So that's why we know in a right triangle that the hypotenuse is always the longest side, because you can't have an angle in a right triangle that's bigger than 90 degrees. You have a 90-degree angle, so the other two have to add up to be 90. So they each have to be less than 90. So the hypotenuse is across from the right angle. It's across from the largest angle. It's got to be the longest side. So what I want you to do on question 6 is to write a conjecture relating the longest side and the largest angle of a triangle. So it would be something to the fact that the longest side of a triangle is opposite or across from the largest angle of that triangle. And we could do the same thing for the smallest side and the smallest angle and the medium side and the medium angle. There's always a relationship between a side and its opposite angle. All right, so in our wrap-up today, our question says, if one angle of an isosceles triangle is 70 degrees, what are all the possible measures of the other 2 angles? And so what that's meaning is if you have an isosceles triangle and you're given a 70-degree angle, it could be the vertex angle or it could be one of your base angles. So there's 2 different possibilities. If it's the base angle, you're going to have to subtract the 70 from 180 and then divide by 2. So that would mean your other 2 are both 55-degree angles. But if your 70-degree angle is one of the base angles, that means the other one is also 70. They add to be 140, so that means that this one is 40. So if it's the vertex angle, the other 2 are 55 degrees, but if it's the base angle, the other 2 are 70 and 40. Is the altitude drawn from the vertex angle of an isosceles triangle to the bases also the median? Yes, when you draw one of the segments from the vertex angle, so if I draw a median, I know it's bisecting this side, it is also an angle bisector, it's also a perpendicular bisector, and it's also an altitude. It's all 4 of those if it's drawn from the vertex angle. Now, a couple of things on your homework tonight. I think the front is pretty self-explanatory, but I wanted to explain a few things on the back. So on numbers 8 through 12, this always seems to be difficult for students. You need to know that these are less than symbols. So you're ordering these sides from the smallest up to the largest. So number 8 would be your smallest side of these choices, leading up to number 12, which is the longest side. So you have to use the angles that are given, and of course you can find this angle and this angle using that triangle sum theorem, and then you can order all 6 of those sides. These are angle measures, or angle symbols I should say here. It's saying the largest angle is angle what? So is it angle A, is it angle B, is it angle C? So you're using the side links to say what the largest angle is. Remember, the largest angle is across from the longest side. So you need to identify the longest side and then what would be the angle across from that. So it might be helpful if you kind of draw a triangle and label it as ABC so you can see that angle C is across from side AB. That might be helpful. But these are angle symbols. So you're just putting A, B, or C here, A, B, or C here, A, B, or C here, A, B, or C here. All right, good luck.